Hey everyone, it's Robert here. If you've noticed, I've been a little quiet on LinkedIn lately, and there's a reason. For the past few months, I've been back in school. Not business school, not an executive program, computer science, specifically CS50, Harvard's full stack computer science program. Learning C, learning memory management, getting as close to the metal, as they say, as possible. And today I want to share that journey with you. Now, you might be wondering, why would, after Tangible built an entire enterprise automation platform, I go back and tackle this marathon? Here's the thing. We built a lot of code at Tangible Labs, Copernicus, our transaction orchestration system, AI-powered contract routing, real-time WebSocket notifications, real cool stuff built on top of frameworks, Flask, React, Postgres, SQL, using Claude to help us move fast. And yet our underlying commitment to first class to engineering presented a question for us. In this AI era that puts a real premium on domain experience and stack architecture, there's still a real need to keep a line of sight on how these systems actually work under the hood, how memory gets allocated, how algorithms scale, why certain design decisions matter. So I made a decision. In my seat, I was going to go back to fundamentals as a check, learn C, build data structures from scratch, understand how computers actually think. Because if we're going to lead in this space, if Tangible is going to help Fortune 500 companies navigate AI risk and automation, we need to be deeply anchored in the code and get as close to the metal as possible. At a deep level, and I have to say, David Mallon and the CS50 team are exceptional educators. This course is hard. I'm not going to sugarcoat it. 200 hours, more challenging than anything I did in studying for any one of the bars I ever took. Maybe more, but the way they teach, the way they break down complex concepts, the problem sets, the support, it's world class. From memory allocation in C, to web development with Flask, to SQL and database design, they take you on this journey where you're not just learning syntax, you're learning how to think like an engineer. If for someone like me, hard science by training, big law partner in charge of the technology and data practice at a large firm for years, now responsible for a company building enterprise software, this was exactly what I needed. And we have a final project, and I wanted to build something real, something that connects to the work we do at Tangible. Fortune 500 companies right now are signing hundreds of SaaS agreements, HR platforms, marketing tools, AI services, and they're facing compliance questions that didn't exist 5 years ago. Does this vendor train AI models on our data? Is there algorithmic bias in their HR software? What happens to our IP when we terminate? Are they GDPR compliant, SOC 2 certified? Legal teams are drowning in these assessments, as are the sourcing teams that they support. So I built AI Risk Review as my final project, reflecting some thinking we've been doing at Tangible, a web application that evaluates SaaS agreements across 5 critical risk categories: data privacy and security, intellectual property protection, AI and algorithmic bias, liability and risk allocation, termination and exit rights. The system walks users through a structured questionnaire covering 20 plus compliance factors. Then it generates a risk score and provides specific recommendations for each category. It's built on Flask, an SQL-like database with proper schema design, user authentication with password hashing, and a scoring engine based on weighted risk factors that I've learned working with Fortune 500 legal teams. Now, this is a demonstration project. It's not calling real AI APIs. The risk scoring is rule-based, but the architecture is there. The database design is solid, and business logic is solid. And more importantly, I understand every line of code because I built it from fundamentals. I wrote the SQL schema. I designed the database relationships. I have implemented the authentication flow. I built the scoring algorithm. Every function, every route, every query, I wrote it and I understood why. And that's the real value here. Not the project itself, but what I learned building it. The CS50 journey taught me how to think about memory, how pointers work in C, why certain algorithms are ON versus ON squared. Don't ask. How hash tables provide constant time lookups. Again, don't ask. How to design database schemas with proper foreign keys and indexes. How web frameworks actually route requests. how sessions work under the hood. These fundamentals matter. They make you a better architect, a better technical leader, a better partner to your engineering team, and it connects directly to what we're building at Tangible Labs. Copernicus, our transaction orchestration platform, handles high volume transaction processing for Fortune 50 companies. We route transactions to legal teams. We integrate with AI for risk assessment. We process thousands of transactions in real time. Similarly, in mass tort, asbestos litigation, we read thousands of claims a year. We analyze those claims. We pull metadata from those claims, unstructured data. We convert that unstructured data into structured JSON files and ultimately into front-end tables. And the lessons from CS50, the fundamentals of computer science, they make me a better architect of those systems. They help me understand when to optimize for speed versus memory, when to use WebSockets versus polling, how to design database schemas that scale to millions of records, how to have intelligent conversations with our engineering team about technical trade-off. This matters when you're leading. You need to understand what you're building, not just at the business level, but at the technical level. So if you're watching this and you're thinking about upgrading your engineering skills, do it. Whether you're in charge like me or an engineer who wants to go deeper or someone transitioning into tech, go learn the fundamentals. CS50 has a cost-free tier. It's online. It is generous in spirit. It is entertaining. David Mallon and his team have created something extraordinary. And yes, it's hard. Yes, you'll spend nights debugging segmentation faults, but you'll come out the other side with a deeper understanding of how computers think. In this AI era, that understanding is more valuable than ever. 2 quick final thoughts. First, if you're building in this space, if you're leading technical teams, if you're making architecture decisions, invest in understanding the fundamentals. It will make you better at everything else. Second, to the CS50 team, David Mallon and everyone who built this course, thank you. You've created something special. World-class education accessible to anyone, anywhere. That matters. If you want to talk about how Tangible Labs can help your company with transaction orchestration or AI-powered automation, reach out. We'd love to hear from you. And thanks for watching this Tangible session. And to everyone else in CS50, good luck on your final projects. You've got this. Now back to building Copernicus.